In the last lesson, we learned about Newton's first law of motion, and we'll just go over it again before we start the second law. Newton's first law of motion states that an object at rest will remain at rest, and an object moving at a constant velocity will continue moving at a constant velocity unless it is acted on an unbalanced force. So here is an object A, and the object A is experiencing balanced forces. So here is force F1 and this is force F2. Now F1 is equal to F2. They are equal in magnitude and they are opposite in direction, so they are balanced forces. Here again I have two more, say F3 and F4. So F3 and F4 are equal in magnitude, but they are opposite in direction, so they too are balanced forces. This object was at rest and it will continue to remain at rest as long as the forces acting on it are balanced. Balanced forces do not cause any change in motion. If balanced forces are acting on an object at rest, the object continues to stay at rest. In the next example, balanced forces are acting on an object which is moving with a velocity v. And as long as the balanced forces are acting on this object, the object continues to move with this constant velocity. The object does not change its velocity. In my third example of the body C, this forces F3 and F4 are balanced. However, the forces F1 and F2 are not balanced because F1 is greater than F2. There is a net force acting on this body. So here the net force is not equal to 0. What would happen in this case? Your object will start moving with an increasing velocity. The velocity will not stay constant. Thus we see that an unbalanced force causes motion. Newton's second law gives us the magnitude of this force. According to Newton's law, the force, which we will now write as F, is always mass into acceleration. So this expression F equal to m into a is given by Newton's second law. So the force acting on the body depends on two factors. One is the mass of the object and the second is the acceleration of the object. Thus we see that greater is the mass of the object, more is the force acting on it, and greater is the acceleration of the object, more is the force acting on it. Here I have two objects, M1 with mass 10 kgs and M2 with mass 2 kgs. And you'll definitely agree, if I want to push both this object, the force required to push M1 will be much more than the force required to push M2, because the mass of M1 is greater than the mass of M2. Since M1 is greater than M2, therefore I can say the force required F1 to push M1 will be greater than the force required to push F2. Now if the force F equal to m over a, m into a, that means acceleration A equal to F over m. Let's study this expression a little more in detail. So we see that acceleration is equal to force over mass, which means acceleration is directly proportional to force. If acceleration increases, more force is needed. Or if you decrease the force, the acceleration of the body also decreases. Now acceleration also is inversely proportional to mass, which means if mass increases, the acceleration decreases. And if mass decreases, acceleration will increase. Here I have two objects having same mass, say 5 kgs, and here too also 5 kgs. In the first case, I apply here a force, say, of 20 newtons, and because I apply a force of 20 newtons, the object will now start moving with a particular acceleration. However, in the second case, to the same object, I double the force. I apply the double force, means I put 20 newtons plus 20 newtons. I increase the force. What do you expect the acceleration to be? Now the object will move much faster with greater acceleration. If A1 is the acceleration in the first case and A2 is the acceleration in the second case, here I will say A2 is greater than A1. Why? Because F2 was greater than F1. So it's very simple to understand. If force is more, the acceleration produced in the body is also more. Here's another example. I have a body with, say, 10 kgs mass, and here I have a much smaller body with 1 kg mass. But however, to both these bodies, I am applying an equal force of, say, 5 newtons. I apply 5 newtons here, and here also 5 newtons. What do you expect? Definitely this body will move much faster. However, this body will go slowly because it has got more mass. So if A1 is the acceleration of the first body and A2 is the acceleration of the second body, you will agree that A2 will be greater than A1 because mass of M1, this is M1 and this is M2. Mass of M1 was greater than mass of M2. So if you apply a same force on two different bodies, the body with greater mass will move slower while the body with less mass will move faster. Thus we say that acceleration is inversely proportional to mass, faster. Here is another example to see how force and acceleration affect one another. So here you have a car, and this car is pushed with a certain force and it begins to accelerate. Its velocity keeps on increasing. Now on the same car, you put some load. When you put some load, you increase the mass of the car, and however, you now apply the same force. But in this case, you will find that the acceleration is decreased. So you increase mass, the acceleration decreases. So if mass is increased, acceleration will decrease for the same force. Let's go over acceleration again. So we saw acceleration is force over mass. So acceleration is directly proportional to force, which means if force increases, acceleration increases. And if force decreases, acceleration also decreases. The second point is force is inversely proportional to mass, which means if mass increases, acceleration decreases. If mass decreases, acceleration increases. So here we see that A equal to F over M. Find the acceleration produced by a force of 5 newtons acting on a mass of 10 kgs. So here we see that the force is of 5 newtons, so we'll put 5 newtons acting on a mass of 10 kgs, so mass is 10 kgs, and we must know the acceleration. The formula of second law says F equal to M into A. So let's put the values that we know. F is 5 newtons, mass is 10, and the A we need to know. So the acceleration equal to 5 over 10. I'll do it here. So acceleration is 5 over 10, which is 1/2 meter per second square. Now force we know is a vector quantity. And why do we call it a vector quantity? Because it has got magnitude as well as direction. So it has got magnitude as well as direction, and hence we call it a vector quantity. Now the SI unit of force is Newton. Let us go ahead and define 1 Newton. Now to define 1 Newton, we start with the expression F equal to m into A. So if we need 1 Newton, if this has to be 1 Newton, we know our mass has to be 1 kg and our acceleration has to be 1 meter per second square, because then when we put F equal to m into A, 1 into 1 will become 1 Newton. 1 kg into 1 meter per second square. So how will you define 1 Newton? We would define 1 Newton as a force required. If I have a body of 1 kg and this body I push it with a certain force, and when I push it with this certain force, the body undergoes an acceleration of 1 meter per second square, then I would say this force must be 1 Newton. So 1 Newton is a force that produces an acceleration of 1 meter per second square in a 1 kg body. So let me go over it again. So 1 Newton is a force that produces an acceleration of 1 meter square in a 1 kg body.